All right, so 9.1, number 5C. So before I do it, were there any problems with A or B? Okay. All right, so it wants to know what the maximum elastic potential energy is. So here's what we know. The problem tells us that the spring has a constant of 50 newtons per meter. The mass that we hang from it is 2 kilograms. And the question wants to know what the maximum elastic potential energy is. It tells us that you stretch it 0.40 meters. Okay? And so my guess is what most of you did is you said, oh, well, elastic potential energy is 1/2 kx squared, kx squared. I know k, I know x, and plug your numbers in, and you get the wrong answer. Right? Yeah. So why? Well, let's take a look at this. Let me read the problem again real fast. So it says, suppose I have a spring with a spring constant of 50 newtons per meter and hang a mass of 2 kilograms from it. So it says, I have a spring, and I hang a mass of 2 kilograms from it. Then I pull it down an additional 0.4 meters and release it, then blah, 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 blah. Why did I emphasize the word additional? Yeah, because when you use this equation, what does the x represent? Not in numbers, but in words. Displacement from the equilibrium position, from the unstretched position. Okay, so is this the equilibrium position because it's not being stretched right now? No, it is being stretched, right? This is the equilibrium position. That's why I said additional. So my x is however far it stretches between here. So right here, it's already got some elastic potential energy because it's stretched to this distance, right? But then on top of that, I'm going to stretch it an additional 0.4 meters. Follow? So what we need to do is we need to figure out what our x max is. And it's not 0.4. Okay? So I'm going to put a little question mark over here because that's a little misleading. Okay? So I guess the question is, how do I find this? Yeah, idea, John?
Do you find the force of gravity from the mass and use that, find the force, and then you see how much this was spring constant?
Okay, so there's an equation that relates force, spring constant, and stretch, right? Hooke's law, right? Does this equation look familiar, you guys? It was in the video too. Right? Remember, the force exerted by a spring is equal to negative k times x, right? So for us, right now, the spring is exerting enough force to support the 2 kilograms, right? So that's 2 times 9.8 equals negative 50 newtons per meter times x. Follow? So what that's going to tell me is how far the 2 kilograms is stretching the spring from this relaxed state. Okay? And if you solve it, you get 0.392 meters. So is that the number I put in my EPE equation? No, that's just how much EPE it has before I come along and stretch it more, right? So, how do I find my x max? Add the 0.4 that I stretch it, plus the 0.392 that the 2 kilograms stretched it, and you get 0.792 meters. And that's what goes into the EPE equation. Make sense or no? Questions? Problems? Concerns? Yeah.
I tried doing that. I just didn't get
let's see, what do we want? We want 1/2. Our K is 50 newtons per meter. 0.792 meters squared. I don't know, anybody do it? Does it work? Yeah, okay, just try typing it in your calculator again. It should work. All right, are we good, you guys? Okay, should I talk about 6? Yes? Okay. Everybody's good with 5? All right.